All right, let's continue on with these product rule examples. This time I'm going to up the abstraction level. F of x is equal to x squared times g of x, where we don't even know what g of x is and we don't care. We can still take its derivative. So same game. The derivative of x squared is just 2x, and we leave g alone, plus next I leave x squared alone, and I need to multiply by the derivative of g. I don't know what that is, but I can still write it. G prime of x. Done and done. I skipped the brackets this time because it was pretty quick, but use those brackets if you need to. All right, one more example. Maybe you can see why this one's different. There are 3 factors instead of 2, but we can still do the product rule. We just need to kind of pick an order. So let's start off by treating this whole big thing as its own factor. So now what am I going to do? dh dt, that's Leibniz notation for the derivative of h with respect to t. You could also use h prime if you want to. It says take the derivative of 1 plus t, that's 0 plus 1, that's nice, and then leave this whole thing alone. 1 plus t squared times e to the t. Parentheses and brackets are your friend, as you can see. Plus, now we leave 1 plus t alone, and we need some derivative of what's left. Some derivative of this 1 plus t squared times e to the t. You see why these brackets help here? We're going to need to do the product rule again, just for what's in these brackets. So let's do the product rule again and see if I can fit it. The derivative of 1 plus t squared is 2t. It's 0 plus 2t, but that's just 2t. Leave the e to the t alone, plus leave the 1 plus t squared alone, times the derivative of e to the t is also just e to the t. All right, brackets really saving me there. We had to do multiple product rules, but there's nothing stopping us from doing that. We could clean this up, but we're not going to. We'll leave it just like that. Really nice. All right, getting better at this all the time. You really do just need to practice enough that it becomes intuitive and fast, but those brackets can really save you some brain space when you start having multiple steps and needing to keep them in order. Okay, we have the product rule. What comes next? Clearly something for division, and that, my friends, is the quotient rule. So the quotient rule is telling us what happens, or what to do, if instead of multiplying 2 functions, we are dividing them. So f of x over g of x, we take its derivative. You ready for this? It is a little bit more complicated than the product rule, but not too bad. F prime times g, just like before. F times g prime, just like before, but now we need a minus. That minus is going to mean that the order really matters. That we take the derivative of the top times the bottom minus the derivative of the bottom times the top. If we get that order wrong, we're going to get a negative because of that minus. On bottom, I didn't tell you there's a fraction, but there is a fraction. On bottom, we're going to get g squared. Put a little box around this. Boom. All right. We'll talk about y in a second, or maybe we won't talk about y. But let's do an example, because it's easier said, I think, than done. In this fun example right here, we have the top function is x cubed, and the bottom function is e to the x. So what this is telling us, in fact, maybe I'll put a little work on the side. F prime in this case over here is of x is equal to 3x squared, and g prime of x is equal to the derivative of e to the x is just e to the x. Okay. Going even further back, f of x is that top function, x cubed, and g of x is e to the x. Okay. So with time you won't need to do all this, but it's nice to write it out explicitly. This formula is then saying, all right, take f prime, that is 3x squared, leave the bottom alone, minus, leave x cubed alone, times the derivative of the bottom. And now this whole thing is e to the x, and we square it all. Cool. Seems a little random, but it works. We could definitely clean this up. This is not a bad answer. We could clean this up. We could factor out an e to the x on top and get 3x squared minus x over e to the 2x. E to the x squared is e to the 2x, but actually one of those cancels, and so we could get 3x squared minus x over one of those e to the x's. Great. That's about as clean as that's going to look. And a lot of times we'll just leave it a little messy unless we need to keep working with it. If this is step 2 out of 6, you definitely want to clean that up because you don't want to carry around something big and messy that you're going to make mistakes with later on. But if we're done, we might leave it in that first form. Okay. Why does the quotient rule work? I'm not going to tell you. We will have a nicer proof in the future. I'm sure whatever book you're using has a proof that is pretty messy. The same kind of reasoning from before works about trying to keep one constant and seeing what happens, but it gets a little weirder because we don't really know how to take the derivative of 1 over g. And so once we understand that a little better, this will make more sense. So unfortunately, I hate doing this, but I'm going to say trust me for now, and I promise to come back and make more sense of it later. But this will help us work with a lot of new and interesting functions. Great. Proof coming soon. You know what's next? A few more examples. Let's find a tangent line of a rational function. That is going to require us to find the slope, or that derivative y prime, and we're going to do the quotient rule again.